Hello, everyone. Thank you so much for joining us, and welcome to today's API security webinar hosted by Process Tempo and Neo4j. Neo4j is, of course, the industry leader in graph database technology, and Process Tempo is a graph application platform built exclusively on top of Neo4j. My name is Daria Chadwick. I am a marketer at Process Tempo, and I am delighted to be joined today by Sami Dega, sales engineer at Neo4j, and Phil Meredith, CEO and founder of Process Tempo. And collectively, we'll be speaking to you about how you can leverage graph analytics to help reduce your API security risk. So on that, here is our agenda for today. We'll start by taking a quick look at why API security needs a reset. From there, we'll hand things over to Sami, who will introduce us to Neo4j and explain why graph is the perfect foundation for your API data. Then Phil Meredith will walk us through how you can actively start to close the gaps that exist between your tools and teams and create a comprehensive API security program with graph analytics. We'll end things with a Q&A session, so please use the chat functionality to get your questions in. We have a lot to cover, but let's begin. So you may have heard that enterprise security teams today, on average, manage around 76 different security tools to respond to cyber threats. Now, many API developing organizations today are starting to follow a very similar tool-focused path. It's not really surprising, though, that we see organizations adopting this approach. They've been warned extensively for years now that APIs were to become the #1 attack vector, and that API-related attacks and breaches were expected to double by 2024. So it's only natural that we'd see kind of an explosion of tools available to help organizations better combat these rising threats. Now, while these tools do play a very effective role, an overemphasis on them can be dangerous. It can often create a false sense of security and leave organizations kind of vulnerable to attacks. The recent T-Mobile data breach serves as a really great example of this. Off the back of, I think, 6 high-profile data breaches in 5 years, T-Mobile committed to a 2-year, $150 million initiative to improve its digital security and its data defenses. They committed this $150 million off the back of also settling a $350 million lawsuit to their customers that were impacted by these breaches. Now, despite all of this, a malicious actor in November of 2022 still was able to manipulate one of T-Mobile's poorly designed APIs to help steal customers' personal information, including customer names, email addresses, phone numbers, dates of birth, account numbers, billing addresses, etc. So this type of breach really underscores the fact that being tool-focused just isn't enough these days. It's not enough to deal with the rising numbers and types of API threats that are on the horizon. But why is this the case? Well, first, being tool-focused can often delay and or block API developing organizations from establishing comprehensive visibility into their API landscape. They might be able to dive in and get a good look at certain areas or specific APIs, for example, but when it comes to their API landscape at large, most organizations today don't have visibility into that. They don't have a comprehensive view. Now, this is a problem because if you don't have comprehensive visibility, it means you can't generate executive oversight. Most organizations today don't have the executive oversight they really need to understand completely their overall security posture. And if you don't have this oversight, it makes it more challenging to organize collective efforts around APIs, to streamline processes, to create robust procedures, and to also, very importantly, intelligently allocate resources when and where it's needed. And if you have insufficient executive oversight, that's only going to lead to gap widening between different teams. As your teams remain isolated in their own bubbles, they're going to continue to maintain their own separate data, their own separate tools. They're going to run off their own individual metrics. They follow the orders from their own individual managers, and they're only going to focus on their own objectives. Now, this gap will continue to grow wider and deeper, and it's going to exacerbate the problem even further. So those are just a few reasons why being tool-focused can be damaging. But again, we know that API security tools can be helpful, and we do very much advocate for the use of these tools. We're stressing here that You cannot just be tool focused. That cannot be the gold standard of your API security program. Your API security program should be one that strives to establish comprehensive visibility, ensure proper executive oversight, and also to really work to bridge the gaps between teams. And so you can overall enhance your API security posture. Only this way will you be best prepared to really effectively secure and manage your APIs as your API landscape continues to grow and evolve over time. So on that, we'll now hear from Sami, who will talk to us more about how Neo4j can be the key to establishing this visibility into your API landscape through the graph. So Sami, over to you.
Thank you, Daria. Hey, everybody, my name is Sammy Dagger, and I'm a sales engineer for Neo4j. So today, we're going to talk about Neo4j and kind of go back to what Daria talked about and how we need to close the gap between development teams and security teams and have a sort of a source of truth for how we manage security today. So first off, what is Neo4j? Neo4j is the originator behind the label property graph, right? We are the first company to take graph theory and implement a full-fledged graph database to manage your data. We are by far the leader in the market with over 50% market share, and we have a number of high-profile customers today who are using our database platform. So you can see on the right-hand side, 20 out of 20 top financial institutions, top retailers, top automakers, telecoms, etc. And you can see a few of the logos below. So to get started, we'll talk about the basics of Neo4j, which consist of really three main things. The first thing that a Neo4j database consists of are nodes, right? So on the right-hand side, we can see that there are 2 person nodes and 1 car node, and they are represented by what we call labels. There are also relationships between these nodes. So you'll see that one person loves another person. A person drives a car, a person loves a car, a person owns a car. And you'll see that these relationships are categorized by a type. The last thing that we'll see are what we call properties. So properties are additional pieces of information that you can append to a node or a relationship. So you'll see, we have Dan who loves Anne, and we can actually append properties to relationships as well. So Dan loves Anne since January 10th, 2017. So why graph for API security? So why should we model our infrastructure as a graph? And what it enables us to do is, first off, identify our most valuable assets or our crown jewels and target security investments, right? We can also generate alerts for the relevant teams, especially since we have the source of truth now and we have the relevant information. We can identify suspicious behavior, reducing the mean time to detection and uncovering insider threats, right? So since we have the source of truth and this data stored in a graph format, the time it takes for a breach to happen and the teams to be alerted is definitely reduced. And lastly, we can analyze and rationalize identity and access management to enforce the principle of least privilege. Okay, so what I like to think about, when it comes to defenders and attackers, is a quote from John Lambert at Microsoft, where he says, "Defenders think in lists, attackers think in graphs. As long as this is true, attackers win." So if we look at the graph below, we can see that attackers actually have the advantage in a lot of circumstances when it comes to breaches and vulnerabilities. So first off, looking at the scope of effort, right? When it comes to defenders, defenders as an organization need to defend every device and every component on the corporate network to be, satisfactory. Whereas the attackers just need to focus on one vulnerability, one open port, one phishing click, right? So they have a much smaller scope of effort and target area to look at. Available time and effort. Defenders are often understaffed and overworked and are fighting for resources, whereas attackers, you have full agencies out there that are dedicated to attacks, right? So they are have a narrow focus and might have a team of 10 or 20 people that are just focused on finding those open ports, finding those vulnerabilities. When it comes to thinking in graphs, typically defenders just think about, what ports need to be covered, what's whitelisted, what are the incoming transactions into the network, right? And attackers typically think, how can I find a vulnerability and what are the connections between those vulnerabilities, right? How can we find just one little part of an entire network that can help us get in and start to spread? So really attackers are thinking in terms of graphs already, right? And the savvy defenders are the ones that are starting to think about graphs as well. Okay. And then the view of the graph, right? So defenders, to have a complete view of the graph, they need a digital twin of the entire environment. Whereas attackers, they discover a graph based on a point of entry. So the defenders can start to finally have an advantage if they equip themselves with a graph, with this entire, topological view of the network. And that's really going to give them an edge going forward. So going along further with cybersecurity and graphs, you can think of the API landscape as a graph itself. So a highly interconnected ecosystem with many variables, many moving parts, stakeholders. This could consist of APIs, gateways, product owners, and it's a complex multi-dimensional network, right? A corporation must have a piece of technology in your arsenal to manage the API and to manage something like API sprawl, for example. So, maybe zombie or duplicate APIs that are no longer used, right? And a graph is an excellent way of managing and handling that. So how about an example of API management in the graph? This is a very simple example, which we'll go a little further into and look at some real kind of world use cases. But basically, you have an API that's in the middle there, and there are different nodes that represent other entities in your network. So you might have an owner, you might have an endpoint, applications, gateways, different metrics. So all of this is really revolving around the API, but some of it is network-based, some of it is maybe source code analysis, ways of evaluating the API. We have different applications that are using APIs. So again, this is maybe starting small, but as you mature, as you begin to connect the dots on in your network and what's using your API, you can start to expand this a little more. So, for example, maybe tracing attacks within the graph, right? Imagine we have an endpoint A, and there are different ports in which our endpoint is using. And API 1, for example, is maybe using that endpoint, okay? So you'll see in the middle there that maybe there are some shared ports between endpoint A and endpoint B. And therefore, there's sort of a connection between API 1 and API 2. They access the same ports in a network, right? So if we think about an attack on, let's say, port 440, all of a sudden, if we're just thinking in terms of lists, we're just thinking about, this port is insecure or this port is affected. But how do we really figure out, where the traced attack can really hit? And truly, it's API 1, it's API 2, it's different endpoints. And the graph, within the graph, you can really, query this and get this information very quickly. Okay, so let's look at another example. And this is dealing with API sprawl or duplicate APIs or zombie APIs. This is an example where we have two APIs with methods, right? And two applications accessing these APIs that are maybe using these methods. So there are two methods in particular that I'm looking at that do similar behavior, right? Both of them retrieve data from a SQL table called customers. Okay. So, different organizations will have different maturity levels in terms of data and information, but we're seeing more and more of source code analysis and parsing these methods and putting them into a database, and a graph database is excellent for this, where basically we're analyzing these methods and saying, well, this is similar behavior, right? These APIs are being managed potentially by different teams and different applications are using them, but they're accessing the same table. They're getting data from the same table in a similar way. So there's really two scenarios that this is beneficial for, right? So the first one is being proactive. Maybe you have a development team who sees a story, on their Jira board, and they're thinking they want to make a new API with new methods. But if we're able to check the graph before the developer picks up that task and see if there's already a method that retrieves data from the customer's table, that can eliminate a lot of wasted development effort. Okay, so being proactive is a good first scenario for reducing API sprawl. Another scenario is reducing duplicate code. So let's say we already have these methods and we already have these APIs that are being used by apps. If we can run a graph data science algorithm on our entire network, we can easily see potential duplicate methods that are being retrieved back to us. So maybe we already have duplicate code and duplicate methods, and that's not a problem. Maybe we weren't proactive in the past. Now we can use graph data science to run similarity algorithms, community detection algorithms to give us an edge going forward and reduce that tech debt. And speaking of graph data science, we have a number of algorithms that our customers are using today, whether it's pathfinding and search, centrality, importance, community detection, similarity, and all of these can help with not only cleansing data and getting the right data for data science, because that's 80% of the battle, but also helping us reduce duplicate code, be proactive, and start to make informed and predictive decisions on our network. So we're going to look at a graph data science example where we're going to be looking at the Louvain algorithm, which is where we can identify communities based on modularity. So the more modular a little community is, the more well connected it is, meaning from one node to another node, there's a path, right? There's a path from every single node to another in this little community. So first of all, I'm just going to look really quick at some pattern matching before we get to the graph data science itself. So maybe I'm looking at relevant owners of a gateway that had a security breach. So I'll go ahead and run the query. And then what I'll see on the screen are the relevant owners. And this is a real sandbox of our graph database. I can start to click around on nodes. I can start to examine, here's my owner, here's my APIs. Maybe I double click the APIs, and all of a sudden, here's the gateway that's shared between APIs, right? So this is a real sandbox, and this is actually displaying and showing our data. Okay. And going a little further, let's look at the data science portion of this and look at the community detection, right? So this is a tool called Bloom, in which we can visualize Neo4j in a different way. But maybe I just start to look at APIs in our network, right? So these are all the APIs, and I can double click them. I can look at the different properties if I want. But what I can do in Bloom is run an easy data science algorithm without actually writing any code. So what I can do is run Louvain, and I can start to apply some settings, change the orientation of my relationships, and I'll apply the algorithm. And now I can apply colors that represent the different communities, right? So what I'm looking at now are different communities that are sort of mapped by different colors. So if I take, maybe a few of these green ones and move them over, if I double click them, I can see a Louvain score, right? And we'll see that they're both under 100, so they have similar Louvain scores. So maybe if I take these two and I look at shortest path between them, I can see that they're similar in some sort of way, right? They have a modularity. Maybe they're sharing the same application, right? So if I look at this connection here, I can see that these two nodes up here are both being shared by the same application. So there's your modularity. Okay. So with that said, I will pass over to Phil, and he's going to go into a deep dive of process tempo and how we can take this a little further.
Thank you. Hello, everyone. My name is Phil Meredith. I'm the founder and CEO of Process Tempo, and I'm going to talk to you today about our API landscape assessment. This assessment is part of a program that we're calling React First, which is a comprehensive approach to help identify APIs that may expose your organization to cyber risk. It's a program consisting of people, process, and technology working together to solve this problem. It's not a technology-only solution. All of this can be found in our Enterprise API Landscape Assessment document, which is available on our website for download. So one of the fundamental problems that likely contributed to the T-Mobile incident and other incidents that have to do with an API being hacked has to do with the gap that exists between the application or product teams and the cybersecurity teams. These two groups use completely different systems that do not talk to each other, and therefore they do not have a shared viewpoint into the state of the overall API landscape. This gap between the two represents a real problem, and this is where React First comes in. We hope to fill that gap and create the transparency required for the organization to stay ahead of this problem. An indication that a gap exists is when companies struggle to answer this very basic question: how many APIs do we have? You really can't secure what you don't know about, so not being able to answer this question is a real problem. Now, why is this question so difficult to answer? Well, a lot of things are standing in the way. Absolutely, having multiple disconnected systems is a big problem. Having no single team responsible for all this is a problem. The fact that employees come and go and the development team is under constant deadline pressure, all this constant change and constant pressure allows these things to fall through the cracks and allows us to push APIs to gateways or to production environments without properly documenting them, making the question very difficult to answer. Another difficult question is, well, okay, what are the state of these APIs? How secure are they? How robust or mature are they? Understanding the state of these APIs is also equally important. So from our assessment perspective, we look at risk indicators and quality indicators to determine the overall health of an API. So risk indicators might include, is the API, for example, publicly accessible? Those APIs might be higher risk than those internally accessible only. Does the API expose personally identifiable information? Is it on a known gateway? What type of authentication method does it use? All of these indicators or properties of an API would give us an understanding of the risk that this API exposes to the organization. And by answering these questions, we can define an API risk score. The same could be true for API quality. One of the factors we looked at is an API even used? You'd be amazed that when we do these assessments, we find these APIs sitting out there, published on a gateway, with very little to no traffic going through them. So basically, these APIs are out there, exposed potentially, and providing zero value back to the organization, and instead just pure risk. So there's a lot of factors that go into the quality of an API, not just the traffic that goes through it, but how many applications leverage it, when was it last updated, what kind of technology does it use. All of these things would indicate whether or not it's a high quality API or a low quality API. So quality is important, but why is it so important? Well, when we find APIs that we want to fix, let's say there is a risk factor that we want to address, we have to set a priority to fix them. And combining risk and quality scores will help you come up with this remediation priority and help you prioritize which APIs you need to address first. So with that approach, we go out and we first connect to and pull information together to start to get this comprehensive view of your APIs. And then we start to assess those APIs based on their current state. And after that assessment, we get a picture of your good APIs, the bad APIs, and those that are somewhere in between. So a good API, well, that's one that's locked down and secure. It's one that's well documented and visible to both teams involved. It's also an API that is reused and has an owner assigned to it, and potentially could be monetized, which is very exciting. Bad APIs are those that are open or not secure. You'd be amazed at how many APIs, for example, we find that have a hard-coded password. APIs that are dark are those that are out there getting traffic that aren't documented and aren't visible. And so that's pretty scary. What are these things doing? We got to shed some light on them. And then unused APIs or zombie APIs, like I mentioned, are those of poor quality that we need to go out and find. And an API scanning tool or traffic tool will have a difficult time finding unused APIs, won't they? And lastly, there's ugly APIs. Those are redundant, poorly documented, improperly categorized, maybe used by a single consuming application, so there's very little reuse. These things might give an indication that it's a poor quality or not so secure API that we may want to address. So to conduct the assessment and to breathe life into the React First program, what we do is we come in with Process Tempo and Neo4j as a combined solution, and we install this solution within the four walls of your organization. And then we connect our application to all the systems that might have API metadata or API traffic or information about the existence of an API. We're going to go out and start pull that data into our common data model. And we're going to be able to do that in an automated fashion and leverage whatever technology resources available to us from an integration standpoint. And then we're going to be able to compile this data and produce it in a set of out-of-the-box dashboards and reports. And that's what you see, these screenshots on the right-hand side. These are going to be some of the dashboards and forms I'm going to show you in the demo after the slide presentation. Let's quickly talk about our implementation before we get to the demo. So first and foremost, it's a maturity model. It's a crawl, walk, run approach. We're not walking in and boiling the ocean. The walk approach is primarily aimed at developing the API catalog itself, getting all this data together and creating a baseline of your understanding of your APIs. And it's from this baseline, then we're going to start to look for traffic that sits outside these known APIs, and that would be an indication of potentially dark APIs that we want to zoom into. And we're going to iterate and automate and monitor this entire effort. And if you stopped right there and didn't continue on with the assessment or with React First, there's a lot of value in just having a single catalog, because now both teams can come together and search this catalog to see if an API already exists and to understand attributes about that API and to determine what to do with it. So a lot of value just in that first step. The second step is, okay, once we have that API baseline, we really want to start to further classify and remediate these APIs. So as part of the classification status, we're looking at all those risk indicators and all those quality indicators, and we're assigning a score, a risk score and a quality score, so such that now armed with these scores, you can set that remediation priority that I mentioned earlier. Now, we will help you build that list, but we'll also help you track the resolution or the remediation effort over time. This is important because we're talking about code here, and sometimes code takes weeks or months to change, and that work could easily compete with existing work or fall through the cracks. And so it's important from an executive perspective or leadership perspective that we're able to look at the actual remediation efforts according to a deadline or milestone initiative. And this way we could evaluate the success of our remediation efforts when they are competing daily with other priorities at the same time. So it's not just about classifying and remediating, it's also providing that oversight. And the last phase is where we continue to manage this environment, but with much less dedicated resources. So we've set up these automated scoring mechanisms. The data is flowing in from gateways and that sort of thing, and we're getting this ongoing picture. And basically, we can now sit back and manage by exception, just capturing those records that need our attention, fixing them, and moving on. So much less effort at this point. But there's also great opportunity now to go after other use cases, somewhat related, because once you have this very rich set of API data, you can now do a lot of interesting things with it. For example, you might want to build a software bill of materials capability where you can look for things like software dependencies throughout your API and application landscape. Can be very useful for you. Having this data can also be very useful in a migration or cloud migration efforts. For example, you may want to migrate your APIs to a single gateway, and that planning and that effort might take months to do. And so having a rich set of data in your hands to help you with that is amazingly powerful. All right, before I get into the demo, it's worth you understanding a bit about the day in the life of how data gets into React first. So one of the basic ways to do that is we get a developer to tell us specifically about the existence of an API. And to do that, they use one of our forms, and they fill out the form. And when they do, a record gets added to our catalog. And whatever information that developer can tell us about it, great, we're going to collect it at that time. And with that, we may be able to calculate a risk or quality score, or there may be a lot of gaps in our knowledge at this point. Another way to get data into the catalog is through an automated effort. So we're going to connect to your API gateways. And when a new API is published to a gateway, it's going to be detected. It's going to be then put into the catalog. And so in an automated fashion, we get records starting to accumulate in the catalog. So once that's done, once a record is added to the catalog, the classification clock begins to start. And the idea is we want to get to a point where we're really comfortable understanding the risk and quality score for that API. And the longer this sits out there, the more risk. So we want to use this burn down chart, which is what you're looking at here, an example to track our efforts to classify things and how long is it taking for us to respond to these classification requests. Now, one of the ways we kind of prod this is we send emails in an automated fashion, or we could send messages to a Slack channel, and we gently poke people to say, hey, there's this API out there. We would like you to do some investigative work for us or tell us a bit more about that API. And if you're the developer, maybe you can publish the Swagger file or any conformance scans that you've done as part of your development lifecycle. Anything that you can do to tell us a bit more about this API would satisfy our needs to classify it. And so that's how an API maybe starts off as red, unclassified, but eventually turns to yellow and green and becomes something that we don't have to worry about because somebody's gone in there and evaluated that this API does indeed fit this risk and quality profile. And when that happens, the API falls off of our classification burn down report. And all this too, by the way, is tracked in our executive dashboards. So the executive leadership is looking at this to see what are the health of our APIs, what are our high risk APIs, and what are our remediation efforts, and how well are we doing against those remediation efforts. So a comprehensive program approach, what you see here is people, process, and technology coming together in a coordinated fashion to address this problem. And now it's my great pleasure to jump into a demonstration of what you just saw. Okay, so I've logged into Process Tempo as Phil Meredith, and based on my permissions, I have access to these two workspaces. One is called React First, and the other is called the React First Executive View. And if I drill into each, you'll see that they're both organized differently. In this particular workspace, I may want to have an environment just for my executive leadership team and provide them just with the links to the dashboarding content that I think is important to them. And then I would hide all the other clutter involved in making these dashboards work. So I would give them access to this particular workspace in a read-only fashion. For the team that's designed or put together to support this environment or contribute to this environment, may have a different way to organize the content. And I may assign these users instead roles like admin or editor, so they can come in and help collaborate to or contribute to this effort. Let me go to the just a quick view of some of these folders. Here's where we put all of our connectors. These might be connectors to the internal systems or external cloud systems, where we may want to both read information from as well as write information to, and I'll tell you how that works. Here's where we organize our dashboards. Here's where we organize our forms, and this is the user interface where we're going to collect that information. And we also can organize the reports and queries that pull from these different systems and that we could use in our dashboards. So for example, I have metrics for the current API count or APIs found without an owner, and just examples of different types of reports that we would assemble to solve this problem. Let's dive into the API catalog dashboard itself. This is the main list of APIs that we've detected to date. In this demonstration database, you'll see that there's 485 total records that we found. And as we look across this table, we could see the various attributes or properties of these APIs. What should pop out are those APIs that have a high or very high risk status, and those APIs that have or expose PII information. I'm color coding or theming those bright red to stand out for my users. As I scroll to the right, you can see all the other attributes and information about these APIs. So this represents the one place to go to do a search, to do some exploration, and to understand if an API exists, and to explore the properties of those APIs. Generally, what's going to happen is this dashboard would be pre-filtered by the API owner or the individual, so that when they click that link, they're only going to see the APIs that they care about. So in this case, there's two APIs that this individual owns, and you see that one is classified and the other's pending. So let's pretend for a second that I'm the owner of this API. I want to be able to change that status. This is where the integration with our forms come into play. So from this dashboard, I could drill to a form, and I have several options, and those options are based on my login credentials. I can go into that form and effect change. So maybe I have looked at all the attributes of this given API, and maybe on this particular date, I classified it. When I click submit, what's going to happen is the database record is going to change. So the dashboard becomes my user interface to explore the data. The forms allow me to affect that data. Now, I mentioned read and write. When I click submit on that form, it doesn't necessarily mean it updates just the graph database. It could update external systems. I could write back to a third-party system through an API connector. I could also have an alert put on a Slack channel that attests to that fact that something has changed. And also, the entire time, every change is kept in the React First log record. So I know who's doing what to these APIs. So it's a combination of these forms. Here's another example. And these dashboards where we start to impart our human knowledge on this environment. And we begin to tighten up and make this API landscape information more accurate. As we do that, the executives will be getting their 50,000-foot view of the API landscape in real time. So we'll see those changes to those APIs, their risk, their classification status. We'll see things like the burn down trends, the burn down charts start to trend, either up or down. We'll see new APIs coming in. We'll be able to see high risk APIs, and we'll also be able to drill down into which department or owner is responsible for those APIs. So this is an example, the API summary dashboard, of a tool that we could provide our executives to interact with that data, to ask questions of the data, to explore and understand where that data came from. All of this is an example of what we could provide as a lens into our landscape. So that might be a lens for our executives. The catalog might be a dashboard for our application team. And the React First Graph Explorer might be useful for those individuals that are in the middle of implementing a change. So they're looking at an API and they want to see the upstream, downstream impact. So this is a view of the graph, and it's showing me connections between applications and gateways and APIs. And let me just do a quick search for an API that contains the word or the letters temp. And it's brought back some results, and it provides a picture of all the interconnections between these APIs and the applications that depend on them. This is extremely useful in two scenarios. In one scenario, if I need to edit that API, I really need to know what's going to be impacted by it. And this view, this section of this view of the graph, shows me those dependencies. I know now what's going to be impacted. I know who to call. I know how to go about editing this API in the most careful way possible. The other thing the graph gives us is it allows us to, as a developer, do a quick search to see if an API already exists. And that's a tremendous value of having the API catalog in graph form. I could see by searching, I could see which APIs expose which methods, which applications connect to those methods. I could see how these applications interact. And then I can drill into that and I can determine, does this API or application, will this give me the functionality that I need for my specific use case? And by being able to search, I can get to that conclusion, whether it's a yes or a no. And if it's a yes, basically, I just prevented a duplicate API from being created. Because today, these developers have no system of record. They have to do their own research. And they have to go sniffing around all these different systems. And you know what? They often find it easier just to simply start coding a new API. So the API Graph Explorer gives us so much value when it comes to exploring the API information. The forms and the integration and that tightly coupling between the graph data we get from those different gateways and internal systems, and that coupling with the human knowledge really starts to give us the very clean, well, the most accurate representation of your API landscape possible. And with that, we could start to begin to fix those APIs and prioritize those APIs that are high risk to the organization. So that was a very quick demonstration and walkthrough of what React First looks like and how it works. There's plenty else I didn't get a chance to show you, but I wanted to save some time for Q&A. And so I'm going to wrap up my demo. Thank you very much.
All right, it's now time for our Q&A session, and we have a couple questions coming in here. So let me take a look. Okay. All right, this first question, I think this one is for you, Sammy. Could you explain how GDS can help us look for anomalous behavior against a given API?
Yeah, definitely. That's a great question. With anomaly detection and fraud detection, we see a lot of that in the banking industry. So it's very similar when it comes to API security and management. You could have some manual data that already, exposes some APIs as being vulnerable or having a former attack. So, we can take that data, maybe perform some, similarity, between one, API or gateway or another, start to get some additional properties in there. So that's one thing. We could also look at centrality, right? So, maybe there's a gateway that's caused a number of, APIs to fail or, be breached. So, looking at things like page rank, right? Neighbors and influence that, lead to one node causing, certain things to happen in your graph or in your network. So yeah, there's a number of different algorithms that can really, help out with anomaly detection.
Wonderful, thank you. Okay, another question. Should I have any data privacy or data security concerns with this whole approach? Who would like to take that one? Phil,
I'll take that one. I'll take that.
Sure.
Data privacy or data security are kind of two different things from a data security perspective. Remember, we're going to deploy this within your firewall, within your environment in the most secure fashion possible. And one of the things that we didn't really talk about are some of the security permissions and role-based security permissions that we add to the solution so that you can have fine-tuned control over who could access that data. So really put this in a very secure environment. From a data privacy, I think the question's probably, and I hear this one a lot, is are we opening up the payload of the API traffic itself and able to look into the data that's going back and forth? And the answer is no. We are just collecting metadata about that transaction, about the path that data takes from one API to another API, just the metadata alone. So no data privacy concerns because we're just focused on capturing the metrics we need to identify or get a picture of that API landscape.
Very helpful. Thanks. Okay, next question we have here is, Sammy, this is another one for you. Could you talk a little bit more about how we get data into Neo4j?
Yeah, great question. One of the beauties of Graph is being able to take these different siloed data sources and bring them together, right? So as a result of doing that, you need a bunch of ways to bring in data, right? So and one of those ways is with Process Tempo, right? They have their own way of taking tabular data sources, mapping those objects out, getting them into the graph. If you need things done in real time, you can use Kafka streams. You could bring in things through different Apache products, Apache Arrow, Apache Hop, different ETL tools. So I mean, this can all be done very quickly in real time, or you can do it on a nightly basis, right? Because we know API data, security data, it comes from a variety of sources, right? You might have ServiceNow, you might have different monitoring tools in your cloud environment. So we try our best to be able to kind of integrate with as many sources as possible.
Great answer. Okay. Next question. Let me see. So, okay, if I already have an API management system that detects APIs, then why do I need Neo4j and Process Tempo? Phil, do you want to maybe answer that one?
Sure. So just about 100% of the time when we deploy the solution, the client already has a number of different tools in place that say they're API management tools and that sort of thing. So one, we need, if that's the case, we need a central place to pull all that information in to get a true picture of your API landscape. Because otherwise all this data is disconnected and siloed across these different systems. So generally, our clients already have some form of API management capability in place. I would also add that it's one thing to identify the existence of an API. Maybe these tools can also ascertain a level of risk, but where they may do a poor job is on the quality side. They may not be able to effectively create an API quality score because they're not designed that way to track information that's needed to calculate a quality score. And the last thing would be the collaboration component that we talked about so much in our presentation, that the gap that exists between the application development teams and the cybersecurity teams. That gap needs to be addressed, and we address it with our collaboration effort and our remediation efforts. And these are capabilities that you won't find in API management systems. So that's why we fit so nicely next to these systems.
Awesome. Okay, another question that we have here is, what are some of the most common challenges that organizations can face when implementing the API landscape assessment, and how can they go about overcoming those challenges?
I'll be happy to jump on that one as well. I guess the biggest challenge has to do with executive sponsorship, probably because of that gap I just described. When you look at the root cause of what causes API security risk, maybe developers doing weird stuff on the app development side, the cybersecurity team constantly on a hamster wheel trying to solve that problem because of that, right? It's a never-ending battle. To really effectively solve this problem requires someone who could sit above both teams and really drive this engagement. So, because that drive will create the collaboration necessary to make this success. So if it's still maintained in one team or the other, it may not have the same success as if both the teams come together. And so I would say that the biggest challenge that we face is just making sure we have the right executive level sponsorship for this effort.
Okay, and we have one other question that's come in here that is asking, so once the assessment is all kind of squared away, what then? Now what? What happens after?
Yeah, okay, great question. This is not a one and done thing. The assessment, as I mentioned, has a multi-phase approach. First, we're going to build that catalog, then we're going to remediate those APIs that we find, and the third, we're going to optimize. That optimization piece is really is a repeatable kind of audit process that organizations need to implement, because despite the most strictest protocols with the most mature development organizations, despite everything that we do to try to solve this problem, we're still going to find developers maybe doing things they shouldn't be doing. And maybe it's just pure misunderstanding, maybe it's new developers or employee turnover, but this should be an ongoing effort to continuously audit your API landscape and continuously try to improve on it. So yeah, what happens after the assessment is we put these practices in place to try to capture those scenarios, but before the bad guys do.
Excellent stuff. Thank you. I think that might be all that we have time for today. Thank you both so much for your time and for sharing all your expertise. So thank you, Phil. Thank you, Sammy. Really appreciate it. Now, while that's all we have on API security today, we do have more available on some other great use cases that can be supported by the Neo4j and Process Tempo partnership. So on that, be sure to join us next week for our next webinar on April 5th at 12:30 p.m. Eastern to learn how Process Tempo and Neo4j can help you plan your cloud migration with confidence. You can register online at neo4j.com/events. We'll see you there.